So we are going to discuss phase change diagrams. So first we'll go over states of matter. So properties like a solid, liquid, gas, what it kind of looks like. A basic, like a general phase change diagram and what makes it up. And then we'll discuss the phase change diagram of water, which is the one that you'll typically be looking at when you're given a problem. And then we'll do practice problems. So first is the state of matter. So I made this table and it shows the state of the matter. So a solid, a liquid, or a gas. Then I gave you some other information that could be useful if you're given another problem. So the density of these different states are different. So you'll have a higher density if it's a solid or a liquid, and a low density when it's a gas. Shapes are indefinite. It depends on the solid, like what shape it is, as well as the liquid and the gas. It's indefinite because it can take up the shape of the container itself. The volume, again, is definite in the sense that the volume is whatever you put it in. So for liquid like water, if you put it inside a glass, the volume of the water is the volume of the glass. Gas, it's indefinite. You can see it here in this picture that versus the liquid and the gas, there are less gas molecules than that of the liquid. So that's why it's indefinite. Intermolecular force strength is also important to know about these properties. Okay. So change in state of matter to remember. These are important phases to note, especially when looking at the phase diagram of water. You're going to see evaporation and condensation. So evaporation is liquid evaporates to a gas. Condensation is when gas vapors collect up together again, and then it forms a liquid. Deposition is from a solid to a gas. Sublimation is from a gas to a solid. Freezing, melting is what we know from a solid to a liquid and liquid to solid. So now that you guys know that information, or just refresh it, we're going to look at a phase change diagram. So what is it? A phase change diagram is a map of the states of a substance as a function where it's pressure versus temperature on the x-axis. So the regions of the diagram will show the different states of matter, the condition it is in. So is it a solid, a liquid, or a gas? And things that you want to be able to recognize on a diagram. And what I mean by recognize is you should be able to identify it on the diagram, like where it is, as well as know what they are. So a triple point, a critical point, and what do the lines separating the different regions represent? So we're looking at this right here. You'll see that we have the triple point here. Triple point is when the substance is in all three states. So it is a solid, a liquid, and a gas. That's the temperature and pressure in which it happens. So when we were talking about regions here, so regions of the diagram, this is one region. So you have your solid region, you have your liquid region, and you have your gas region. Then up here, it's not shown, but there is a critical point for some substances, and it will typically be shown in the upper right corner. Okay, so what these arrows are indicating is if I tell you at 1 atm And at 25 degrees Celsius, this substance is a liquid. If I say that, let's say now you're looking at it at 0.006 atm at 25 degrees Celsius, the phase change is from a liquid to a gas. That would be the phase change. So it's now a gas. So that's how you would navigate. The same applies if you're going. So you can go up or down or left to right. Okay. So let's look at the phase change diagram of water. This is what it looks like with all those points indicated. So you have your critical point, liquid, water, thermal freezing point. Now I'm going to show you what it looks like earlier when we were talking about this right here and why you should know it. Because if they're asking you something when the point in which sublimation occurs or evaporation occurs, you can find out which direction it moves. So right here, you'll see that the critical point is here. So at this state is a supercritical fluid. What that means is that it's at such a high point that your substance is this interesting fluid, I guess you could say. What I did here was I labeled when vaporization occurs. So it's going from a liquid to a gas. Condensation occurs when you're going from a gas to a liquid. Melting and freezing. And here is when you're going from the gas to the solid and solid to a gas. That would be sublimation and deposition. So this is typical phase diagram of water. Okay.
Sorry, which part is a gas? Which part?
Well, is the what?
Gas.
Gas is here. Water vapor?
Water vapor is gas.
Yeah. So it's this entire section right here.
Okay, thank you.
Yeah. Okay. So now we'll do practice problems. I'll give you guys 5 minutes to do this one. This isn't a calculating or anything. What I'm just asking you is, given the information, can you guys see? Okay.
Yeah.
I'm gonna pause it now. So this is the answer. The answer is D. Okay, so the answer is D because I'm going to show you guys a visual. So on the graph, what I did was I drew a point of where, so here is, I indicated approximate value of about 925. Here's about 175 degrees Celsius, right? So let's say if it's at a constant temperature, we'll assume that it's at 175. That's the constant temperature, but the pressure changed. So what I did was I indicated where the pressure was here to say that's approximately 760. If you move this line down, you can see it's going from liquid to gas, right? I think this was the best visual representation of, and that's how you get your answer. So you go from a liquid to a gas. Because originally you were a liquid. You were liquid. Yeah, so now you have liquid to gas, and that D is your answer. So if you guys got D, then that's right. Did you guys get anything differently or no? You guys are all good.
Okay. Question. So when we face such a kind of problem, first we have to look at the temperature.
Yeah, so look at the temperature that they're asking for and the
Yes,
pressure.
and then look at the pressure, right?
Mm-hmm.
Yeah, because when we look at the temperature, if it go up or go down, we know where it is in the gas,
Yeah.
in the solid or in the liquid, and then we look at the pressure. If it goes up, it is from where? It's going down, it is from where, right?
Yeah, so in here, they gave you like a starting point. They told you that the sample of the substance in the phase diagram was at 175 to 925 at 925. So that's why I started here.
Yes.
And if you decrease the pressure with keeping the constant temperature, so same temperature, if you decrease it, then you just go from a liquid to a gas.
So let's say if the temperature is less than 145.
Yeah, so if they tell you that
it is still from solid to
a liquid to solid. So let's say we're starting here, right? If they tell you that the pressure, the temperature decreases to to 90, okay, 90 degrees Celsius, you go this way. So you go from a liquid to a solid, right? Liquid to solid, 90 somewhere here. Yeah. Does that make sense?
From liquid to solid.
Yeah. So we're not going from gas, or are you asking from gas? It can go from gas to solid. It just depends on where's our starting point. I started from here. So if our temperature,
the problem, yes, the liquid to gas.
yeah. So if they say this dot represents 90 degrees, okay, it's at 90 degrees at 925 millimeters of mercury. If we go from here to here, we're now from a liquid to a solid, right?
Mm-hmm.
Yeah. Okay. So we're going to move on to the next question. Okay. So remember what I was saying earlier of a phase diagram and know your points? So this is the general structure. You always have the solids, liquids, and gas at the same parts, so it doesn't matter how big or small it gets. So I want you guys to identify those points. Give you guys 6 minutes. Okay, let's go over the answer. I'm going to share my screen again. Start sharing again. Can you guys see them? So A, did you guys all put solid?
Yeah.
Yes.
Yeah. So C is gas, B is liquid.
C is gas.
D is that supercritical point fluid.
Does it make a difference if you just wrote like critical point?
If you put critical point's right here. I think,
Okay.
yeah.
Supercritical fluid.
Okay, so there's like
actually,
two.
Yeah, actually, I'm not sure about the. I think it can be fine if you put critical point, but this area is supercritical fluid. Yeah, I think what the critical point indicates is when supercritical fluid is like when it's produced, when it has been reached. So the range onward from here will be supercritical fluid.
Okay.
Can we use liquid instead of fluid?
Yeah, so.
Let's say supercritical liquid.
Oh no, so it's supercritical fluid.
Mm-hmm.
Yeah. So this point, what was it?
I was gonna say, is it fluid because we don't really know like what's in the.
Yeah, so it's kind of like you guys know the the triple point?
Yeah.
So it's kind of like that, but it's at a higher pressure. So then things are all like fluid.
Mhm.
It isn't really a liquid anymore. So it's like a kind of weird in between.
Okay.
The
So
question,
E,
please.
what was it? Sorry.
I mean, this one.
E?
A, yes, supercritical fluid. It is, yeah, between
So E,
between liquid and solid. And then you have the wording is supercritical fluid. But
yeah,
this
so
one, this,
D is the region.
no, not D, I mean E.
Yeah, so E is the state. So on this line, if it's on this line, it's between a solid and a liquid. It's
Yes.
that moment, yeah. When ice is partially still liquid and solid.
Uh-huh. But why don't we answer like this one? I mean, something in between that means solid and then dash liquid.
Yeah, so we just answer it like that is because it's in a state in between. So it's both solid and liquid at the same time.
Ah, okay, okay.
Mhm.
Okay, got it, got it.
Yeah.
And D is critical point.
Yeah, D. So D would be a supercritical fluid.
Uh-huh. How about critical
This
point?
critical point is right here. This is the critical point.
Ah, okay, okay, got it, got it.
That's critical point. Yeah.
Uh-huh, uh-huh. Okay.
G is your triple point. So it's when it's a solid, liquid, and gas. Ooh, I missed an S for gas.
I have a question about F.
Yeah. Mhm.
So on some of the ones that I've seen, they call that F area the sublimation curve. Could you put that and it be correct?
Yeah, it would. So that's I believe that's only if we're labeling a water phase diagram.
Oh, okay.
So let's go back. So right here, right here, this is where you're looking at. So this phase diagram, the vaporization curve, this would be when a liquid is going between a liquid and a gas, right? So earlier, what we were labeling were phases. We weren't labeling like the specific name of it. It's like what phases is it stuck between
Oh, I
with the
see.
substance. Yeah.
Okay.
So this would be a sublimation curve from a solid to a gas. Fusion is when it's melting. So it's between a solid and a liquid. So you can name them these curves. Yeah.
Okay. For T,
Yeah.
can we say
Mhm.
triple point instead of solid liquid gas?
Yeah. So triple point just means that it's when the substance is a solid, liquid, and gas at the same time. So remember the question is asking the points in the phase diagram. So you can do either. What we just did was labeling some of the phases for each point.
Okay, thank you.
Right. Okay, we'll go on to the next one. My suggestion for this, draw lines on the chart about where these things are. So that will help you identify what phases. So phase change, what I mean by that is it going from a liquid to a gas, or is it going from a gas to a solid and so on and so forth? Okay, so 5 minutes. So kind of similar to the first problem, what I did was I first drew the lines for all of the constant temperatures points that it was asked for, right? So we have 0.05, negative 40, and 40. Then what I did was, because it's saying varying pressures, I just drew a white line. You can see it as a dot. I just drew white lines because we have three different temperatures, and I wanted to show you guys all of it. So let's say the white line is where a point would be. If you go from top up here let's look at -40 first, okay? You can see that it's on the line, and if this continued larger to a higher temp, this would actually go into liquid.
Oh,
Yeah, so let's see. So like if it continued like that, because you can see that it goes in, so higher pressure means the line is different right there. So then this would be blue. This would be purple right here. So that would be liquid. So for -40, you're going from liquid to solid to gas. It doesn't matter which order you put it in. It's a liquid, solid to gas. It goes through all of it. At 0.005 degrees Celsius, you're going from your gas, that brown part, to a solid for briefly, and then it goes to a liquid. Again, it goes through all of it. And at 40 degrees Celsius, you just go from a gas to a liquid or a liquid to a gas, whichever way you stated it. You guys all get the same? Or if you missed it, maybe it was for the -40 summary.
yeah. I mean, on the -40, I missed the liquid part, but the 0.005 degrees Celsius, I wasn't sure where to put that on like the temperature.
Yeah.
I guess that's where I need help a little bit. Like, how do I know where the temperature goes or something?
So here, it's such a small gap right there that they give you, but what you can see though is that it can't be the triple point. So triple point is at 0.01. So what you just know is that it isn't on this side, because that once you pass 0, it's a negative.
Okay.
So it's in between here somewhere. So you can just put the line, doesn't matter where. You can just indicate, okay, somewhere in there is 0.05. So even if, no matter where you are in this area, you have all three phases.
Okay.
Yeah.
Oh. So like, I guess like somewhere right there's 0.0.
Yeah.
And then I'm adding, or I guess counting backwards, you would say? Because I thought 0.005 was after 0.1. I mean, 0.01.
So
You know what I mean?
think of it this way. So the more, so because 0.005 is smaller than 0.01.
Okay.
Excuse me.
Yeah.
Yeah, the first one, second one, I got it. And -40
40.
degrees Celsius. Can you say it again?
Yeah. So
Yeah, from gas
here,
to solid, I got it. But
yeah. So if
liquid.
you extend this line here, oh my AirPods stared at me.
Oh.
Okay. Can you guys hear me now?
Yeah.
Okay. So the reason why it's from gas to it goes all three is because if you extend this line right here, it will go into liquid. So here I continue to draw the black line for it to continue. And what you'll see is it goes like this. It goes inwards. So it's going to make the solid part smaller as the pressure increases. So what that means is that if you continue this straight line like we do here, from 40 degrees, -40, it will go into the liquid.
Okay. And this one, it is not necessarily 0 degree, right?
The 0.005?
No, I mean zero degree. This point, I mean, when we have a graph like this, it is not necessarily 0 degree at this point.
Y- At
You see my mouse?
no, I don't. Can you annotate?
How do I annotate?
Click. You're on your computer.
Yes.
On my share screen.
Yeah,
here,
yeah. I mean this point. It is not necessarily 0 degree, right?
Okay, wait. I can't see the point that you're. Oh, okay, there you are. Oh, it isn't. Yeah, it isn't necessarily 0. So it's because right here we indicate that 0 degrees is here.
Oh, okay.
Yeah, it just depends on your graph and where you put your temperature.
Okay. And then, for example, because this one is not clear, so we have to estimate.
Yeah.
Negative 40 degrees Celsius. For example, if I estimate here, and then I draw a line up, and it doesn't, you know, cut the
Yeah. So if it
diagonal
doesn't
line.
go in like directly, I think gas to solid would also be an acceptable answer.
Sorry, again.
Gas to solid would also be an acceptable answer if you're going from here, that line. Sorry, that I can't draw. I don't see the thing on here. So going from there, that would be acceptable if you put gas to solid too.
Okay, got it. So, but the answer is only one answer.
Yeah. So the reason why I did that was because if you look here, the scale for the 100 is pretty big. So if you did 50 here, 40 is around here. And if you make it equal distance, you would still be within the range to cut through.
Okay, got it.
Okay, so let's go on to the last problem. Supercritical fluid. And I drew the points for approximately where they are at. I didn't draw the lines because they looked too messy. I removed them. Did you guys all get the same answer? So, okay, about 20 degrees is around here. Because 50, 25 is here. A is a gas. Oh, sorry. A should be a liquid. My bad. I put it at the wrong spot. It's 1,000. 1,000 kilopascals.
Sorry, why 20 degrees Celsius is liquid?
I'm sorry, it's not a liquid. I put it wrong. It's supposed to be a gas.
Yes, it should be a gas.
Yeah, it should be a gas.
And B
is also a gas. My bad.
Yes.
Yeah.
And C is a gas, right? D is
gas. D is gas. F is gas.
D. Okay. D
is solid.
No, D is minus 40.
Negative 40.
500. So 500. It should be gas. D.
Yeah.
Yes.
D is gas. Yeah. If I gave you guys, let's do a G, okay? If I gave you guys 24 degrees and 125,000.
Yeah, the supercritical fluid.
So, but it's at 24 degrees Celsius.
24, so it's here, around here.
Yeah, so it's around here, right here.
Yes.
So if you draw the lines.
Okay.
So it should be a liquid.
Be a liquid.
If I gave you guys around so you can see that they're split in half. So this is 25. So that's the triple point. So here, if I gave you guys probably around 40, that would go into supercritical fluid.
But okay, for a test, usually they give you this information, right?
Yeah, they'll give you the graph and they'll ask you to look at it.
They give you the label of supercritical fluid, liquid, and solid and gas. They will label all of this, right?
Typically, yes. Or sometimes they'll actually ask you to label. So let's look at the challenge problems. I gave you guys 2 challenge problems. And one of them is actually you have to draw your own phase diagram, given the information provided.
Okay.
So you guys can screenshot this, but again, this is recorded, so you can just go to the end of the recording when you guys receive it.
Okay.
You guys are I asked you guys to sketch the phase diagram for nitrogen. And my question is nitrogen a liquid? Is in the liquid state at 1 atmosphere for the pressure? Okay, so, and then one more question. So this one, I gave you guys, you can also be given this, like something like this chunk where they section the parts and you have to be able to identify what they are. And that's the end of our workshop. Thank you for coming.